Welcome. Hi, Jonathan. So you created the first TPU at Google, and now you've created the first LPU at Groq, first of many we hope to come. That's the intro I'm going to give you because I feel like you've got a little demo for us, and you're gonna really show the audience what you're working on.
Yeah. So thank you, and so good morning. Come on, we can do that louder. Good morning. Awesome. All right. So why are we here today? Seriously, why are we here today?
We're going to show what AI is really like.
That's right. We're going to show what natural AI is like for the first time. You'll have never seen this before, and it's going to be pretty mind-blowing. Now, why don't we just jump right into it? All right. So while it's warming up, you've all experienced AI, but you're about to experience real AI. And... ...
Hey, I'm Groq.
Wrong one.
You can...
So far, so good.
Well, we already had our tech mishap for the day. Give me 1 second while I'm pulling this up. So what you're going to hear here is existing open source models and proprietary models running on LPUs, our chips.
Hey, I'm Groq. You can talk to me like I'm a person. How can I help you today?
Yeah, can you tell me a little bit about Doha, Qatar?
Sure, I'd be happy to help. Doha is the capital city of Qatar, a country located in the Middle East. It's a modern, rapidly developing city with a rich cultural heritage.
I'm going to interrupt you.
Doha is known for its impressive skyline.
Can you tell me a little bit about the soccer, the World Cup thing that happened here and the buildings that were built?
Absolutely. The World Cup is an international football soccer tournament that takes place every 4 years. In 2022, Qatar will host the tournament, making it the first time a Middle Eastern country has ever hosted the event. To prepare for the World Cup, Qatar has been investing heavily in infrastructure, including the construction of several new stadiums. These stadiums are designed to be state-of-the-art, with advanced cooling systems to keep spectators comfortable in the desert.
Can you tell me what we can do with all those buildings after the soccer event is over?
Certainly. After the World Cup, Qatar plans to convert the stadiums for other uses. Some will be used for other sporting events, while others will be repurposed for community use. For example, one stadium will be transformed into a public park with a sports complex. Another will become a university. These plans aim to ensure that the benefits of the World Cup extend beyond the tournament itself.
That's some pretty good information, but what I'm going to ask you to do is I'm going to ask you to use your imagination. I want you to imagine a future city 10 years from now. I want you to imagine the experience of someone landing at the airport and what it's like for them in a city that's built around artificial intelligence, from the first person point of view.
Sure, I'd be happy to help you imagine that. Imagine stepping off the plane in Doha's futuristic airport. As you walk through the terminal, you're greeted by personalized holographic signs that welcome you and guide you to your destination. Your luggage is automatically collected and delivered to your hotel. As you leave the airport, you're greeted by a fleet of autonomous vehicles that transport you to your hotel. Checking in is a breeze as facial recognition technology identifies you and your room is automatically adjusted to your preferences. During your stay, you interact with AI-powered personal assistants that anticipate your needs and make recommendations based on your interests. You explore the city using autonomous public transportation that adapts to real-time traffic conditions.
What I want you to do is I want you to pretend to be the AI that greets me when I land at the airport, and we're going to have a conversation. Can we do that?
I'm an AI language model, so I can definitely play along. Go ahead and ask me a question as if you've just landed at the airport, and I'll respond as the AI greeting you.
Thanks. So how do I get to my hotel? I think it's the Waldorf.
Welcome to Doha. I see that your hotel is the Waldorf Astoria. A driverless car is waiting for you outside the terminal. It will take you directly to your hotel, and the vehicle is equipped with a virtual concierge to provide you with any information you may need during your journey. Shall we proceed to the vehicle?
Yes, and actually, I'm going to be having dinner with 3 guests tonight. My friend Emil is going to be there. And also myself. Can you book a reservation at a Michelin star restaurant?
Of course. I've made a reservation for you and your guests at a Michelin star restaurant called Item. It's located in the Museum of Islamic Art. The restaurant is known for its innovative French Mediterranean cuisine with Arabic influences.
Who's the chef?
The chef has received numerous awards. The chef at IDM is Dimitris Katravisis. He's a renowned chef known for his innovative and creative approach to Mediterranean cuisine.
Okay, now what I'd like you to do is I'd like you to write a poem about the heroic audio-visual team that helped get all of this set up last minute, and the stories about finding a sound card, which was essential to make this work.
In the heart of the night, a team of heroes, with wires and screens, their battle gear, a quest for a sound card, a crucial piece to make the audiovisual magic no doubt cease. Their minds raced, their fingers flew as they searched high and low, no stone unturned, but for the elusive card, the missing link, to bring the vision to life, the clock was ticking.
I think I know how to make this better.
And then,
what is the type of poetic verse that's used in Edgar Allan Poe's The Raven?
the type of poetic verse used in Edgar Allan Poe's The Raven is called trochaic octameter. It's a type of meter in poetry that consists of 8 trochees per line. A trochee is a metrical foot that consists of one stressed syllable followed by one unstressed
rewrite the poem that you were just that you just made up in the same style and verse as The Raven.
In the depth of the night, a team of heroes with wires and screens, their battle gear, a quest for a sound card, the crucial piece, no doubt to cease, their minds raced, their fingers flew, as they searched high and low, no stone unturned, for the missing link, the vision to bring to life, the clock was ticking. In the shadows they toiled, the clock hands spun, their spirits never faltered, their resolve unshaken, their mission clear, their goal in sight, their efforts rewarded, the system came online, the night was broken.
Okay, now tell me, why is it so important for AI to be fast? When it's low latency, how does that change the experience?
Low latency or fast response times is crucial for AI for several reasons. First, it allows AI to process and respond to information in real time, which is essential for applications such as autonomous vehicles, where split-second decisions can be the difference between safety and danger. Second, low latency improves the user experience by making interactions with AI feel more natural and responsive. For example, a slow-responding virtual assistant can be frustrating to use, while a fast one feels more like a natural conversation. Finally, low latency can also improve the efficiency of AI systems by reducing the time it takes for them to process and analyze data, allowing them to make decisions faster
thank you.
and more
I'm going to
accurately.
ask now, my friend Emil here would actually like to ask you a couple of questions. Is that okay?
Of course. I'm happy to answer any questions Emil has. Go ahead and invite him to ask me anything.
Hi, Groq. What's the population of Qatar?
Hello, Emil. Bye. The population of Qatar is approximately 8 million people.
Can you tell me a little bit about the dinner I was about to have with Jonathan? What kind of dishes can I expect to eat there?
Certainly. I'd be happy to help. I made a reservation for you at IDM, a Michelin star restaurant in Doha. IDM is known for its Mediterranean cuisine with Arabic influences. The chef, Dimitris Katravisis, is renowned for his innovative and creative approach to meta cuisine. At your dinner with Jonathan, you can expect to enjoy a variety of dishes that showcase the best of Mediterranean and Arabic flavors.
Will there
Some
be hummus?
examples of dishes that IDM is known. I'm not sure if jealous will be served at IDM. However, the chef is known for incorporating traditional ingredients and flavors from the region into his dishes.
Can you combine
It's possible that
two
gelatinous
random
included-
concepts for me? Hummus and death.
Certainly. I can certainly try to combine those two concepts for you. Here's one possible interpretation. The inevitability of hummus, a culinary dance with death. In the beginning, there was only hummus, a simple dip made from chickpeas, tahini, garlic, and lemon juice. But as it spread across the world, it became more than just a dip. It became a symbol of unity, a
Has
common
anyone
ground for people
died
of all backgrounds
by
to gather
just
around
eating
and break
hummus?
bread together.
Or too much hummus?
No, there have been no reported cases of anyone dying from consuming too much hummus.
Maybe
While
I'll be
it's
the
possible
first.
to eat too much of any food and experience.
Okay, Jonathan,
I wouldn't
how do
recommend
we
trying to be first
pause
person.
Okay.
Groq so we can ask you some real questions? I feel like I'm not
one last
participating as much.
one last question. So, what was the question that I asked you about the importance of latency?
You asked me about the importance of low latency in AI and how it affects the user experience.
Okay.
You asked about the benefits of low
So
latency in AI
summarize
systems,
the entire
including real-time processing,
conversation
improved user.
that we've had in a single short sentence.
We discussed the World Cup in Doha, Qatar, the repurposing of stadiums, the future of AI in cities, and the importance of low latency in AI systems.
All right, thank you very much. You've been very helpful.
You're welcome.
Okay, Jonathan, so that was interesting. I want you to talk a little bit about what's unique here, because I think everyone in the audience has played with chatbots. You've emphasized the speed, and earlier this month, Groq's chips went viral exactly for that, for how quick they are. So can you talk a little bit about what are you developing and what is not under Groq's domain? Like what is Groq building, and what are all the other puzzle pieces that are coming together to make this possible?
So we build the chips, the LPU chips, or language processing units. The way to think about it is when you create one of these AI models that can speak to you, you're creating it out of a bunch of components: a large language model, text-to-speech, a speech-to-text, an end pointer to determine when you're done speaking. All of those are done by other parties. Some of the models that we're running are open source. Some of them are done by small companies that are proprietary. And what we did was we took the best of those and brought them together into a single unified interface with one of our partners, Vappy.ai, DeepGram, PlayHT, and Mistral. And we just make it fast. So the LPUs are about 10 times faster than GPUs when it comes to inference, or the actual running of the models. When it comes to training them, that's a good thing for GPUs to do. But when you want that natural speed, you need LPUs.
So LPUs are your chips, and you've been building this for 8 years now. So tell me how much of the focus has been on generative AI today, and how much of it has been 8 years ago when you first started the company? How much were you caring about generative AI?
Originally, we didn't know that generative AI was going to be that important. The term didn't really exist. The best example was the AlphaGo competition between Google and between Lee Sedol, the world champion in Go. So I actually created the AI chips that now power Google. And right before that competition, there was a test game, and Google lost, but Google was running on GPUs. We ported that software over to the chips that we built at Google, and we won all but one game. The reason that we won those games, though, was because the moves were creative. In fact, in the second game, there was a move called the shoulder hit, and it's actually still spoken about today as a really beautiful move that came from a computer and software. And so that was an example of generative AI. We just didn't have words for it at the time. As we were building the chips at Groq, what we knew that was going to be important was inference, which is actually the running of the models. And we knew that speed on very large models was going to be important. And then up until about a year ago, we were getting really worried that the big, large models like were used to play in AlphaGo weren't going to become real production, monetizable things. And then large language models happened. And all of a sudden, speed mattered for very, very large models that were doing generative AI.
So what percentage of your business is generative AI today?
Well, it's probably 99.999%.
And when you first started?
When we first started, it was probably 0.001.
So what did you first start? What was your focus on when you first started? Where were the inference chips that you were building? What did you think were the applications going to be?
So when we first started, one of the applications where it was obvious that you needed speed was self-driving vehicles. And those self-driving vehicles were using a large number of chips. So our idea was we'd put a large number of those chips in the trunk of a car, network together, super high speed, and everything would be great. And then we discovered that when you're deploying things in a vehicle, they want a lot more from you than in the data center, but they want to pay you less. So we decided, let's start with the data center where it's not as constrained of an environment, and they don't try and be so cheap.
So recently Sam Altman was in the news because there was a story that he's trying to raise trillions of dollars, which would be, a first, for a chip project to kind of scale up AI chips across the globe. What are your thoughts on needing trillions of dollars for a chip project, given that your company literally builds chips?
I have two answers to this. First, $7 trillion And then secondly, we could do it probably in 700 billion, which is a bargain. And our next gen chip is even 10 times more efficient than this gen, so maybe only 70 billion.
So you're asking the audience for 70 billion and you could conquer the world?
Let's get started with, let's start with 7 billion and work our way to 70.
Okay, that's fair, that's fair. So you started the company 8 years ago. Could you talk a little bit about this capital that you've raised, not the 7 billion, but the capital you have raised so far? What kind of moat have you been digging over the past 8 years? Like what's stopping, you previously worked at Google, what's stopping Google from building its own LPU, Amazon building its own LPU, Microsoft and so on, or even OpenAI, or just another startup that raises more money than you have and just kind of tries to beat you to the punch? What have you been doing for the last 8 years that sets you apart so they can't just catch up by pouring money on the problem?
All right, that's a great question. A lot of people will ask us, what's your secret sauce? And our answer is we don't have secret sauce, we have 11 herbs and spices. There's a lot of things that we've done differently from, we started spending the first 6 months working on the compiler, and then we built a chip around the software. That's unique. The way that our chips are interconnected is unique. So we don't have external switches. They're all built into the chips. We've done away with the need for CPUs to control our chips. We've made an orchestration system that allows us to run these large models automatically. So when we can compile across hundreds or thousands of chips, and whatever's most cost effective, we win at. The classic answer is we also have a lot of IP protection. We have 70 patent families, but that's not what makes it hard. What makes it hard is, even though we knew exactly what we were doing and what the desired outcome was, we actually had to go through about 4 different compiler teams in order to make this work, because the intuitions keep driving you towards what you know, the way GPUs are programmed. And if you program that way, it's not possible to get the performance that we get. It's just counterintuitive in almost every way. And you see this, even though we've gone viral this week, there's a lot of people posting, there's no way that this could possibly be cost effective. But that's a little bit like saying, because of the number of chips, that a factory can't be cost effective to build cars because a factory is expensive. Because we're so much faster per chip produced, we're able to get a better cost basis and energy basis.
Yeah, so anyone in the audience can just go to Groq.com right now and try it. I've noticed that after you went viral, you actually added a dialog box that you have to sign up first. Is that because people were abusing the service, or did you just have too much demand, you couldn't keep up?
Up until I think this weekend, we had it completely, you don't even have to log in.
Right.
And we went from 8,000 new signups the week before, or new users, to 400,000. So it was a really rapid hockey stick. What we noticed was people started putting a bunch of scripts on GitHub and other places. We found about 18 scripts that people had written to try and use our website without going through our API. So we added a login, some bot detection and things like that, but we still have about the same number of users. There's a small number of actors who are trying to use most of the compute, but right now you can sign up, it doesn't cost anything, and it's fast.
So your former employer, Google, launched Gemma, its open source kind of competitor, open source AI models. I noticed that on Groq's website, you can't use Gemma yet. It's been about a week or two since they launched it. What's stopping you from rolling that out? Because I know you have Meta's open source models and other open source models, so why can't someone just try Gemma, for example, on Groq's website yet?
So whenever a new model comes out, we do get it working, we compile it. So we actually have Gemma working internally. We haven't exposed it because it was acting in a couple of odd ways that we weren't sure was right. And this also happened when Code Llama 70 billion came out, and we were like, oh, did we do something wrong? It turns out the model just doesn't like to do, like I asked it, write a tic-tac-toe game in Go, and it said, I can't do that because I can't support gambling. So it was a little overly safe,
right?
And that was preventing, and we didn't know if that was us or them. Now we know it was them, so we haven't made that available. Same with Gemini, it's not quite doing what we want, and it wouldn't be a good experience for our users, and we're waiting until it gets better. We'll probably put it up so people can see the speed. It's really, really fast on our hardware, but until we get better results, we're probably not going to make it generally available.
Okay, I see we're at time now, but I just want to ask you one last question. I mean, the demo took a little while. I guess I'm curious, what are you most focused, what should we expect from Groq this year? We saw what you've done, we see the speed. What's your next focus other than kind of showing it off to the world?
Scale. We were going to be deploying 42,000 LPUs this year, and we confidentially, don't tell anyone, we had a convertible note open that filled in less than a week. So now we're talking to people about going much larger. Our intention, if we can, is to deploy over 220,000 LPUs this year. And given how much faster they are than GPUs, that would be equivalent to more than all of Meta's compute. And next year, we want to do 1.5 million, which would be more than all of the compute of all of the tech hyperscalers combined.
Wow, okay, so that's something to look forward to. Thank you, Jonathan.
Thank you.